In our last video, we saw how we can write numbers using scientific notation. Scientific notation was just a simple way to write very large or very small numbers. It makes them easier to work with. Today we'll see how that's true when we want to multiply or divide these numbers. Multiplication is actually very simple. We simply begin by multiplying the two decimals. 4.7 times 2.9. That gives me 13.63. Then we multiply the powers of 10. 10 to the 6th times 10 to the 8th. When we multiply things that have the same base, we add the exponents. 8 plus 6 is 14. So the product is 13.63 times 10 to the 14. But wait a minute, you say, that number's not written in scientific notation. Well, you're right. We have to move our decimal point one place to the left, because the number in front of the decimal point has to be from 1 to 9. So 1.363 times 10 to the 15th. You might be wondering a nice easy way to remember what to do to the power of 10 when you move your exponent. Well, I'm always reminded of my friend Lars. Lars is from Sweden, and his name always tells me exactly what to do. If I move my decimal to the left, I add to the exponent. If I move to the right, I subtract from the exponent. Left add, that's the LA. Right subtract, that's the RS. And there's Lars. He's always there to help you. Division is also very simple. We simply divide the decimals, 1.5, divided by 7.5. That gives us 0.2. Then we divide the powers of 10. When I divide, I subtract exponents. Negative 8 minus 5 is negative 13. Once again, I know what you're thinking. That number's not in proper scientific notation. I have to move my decimal point one place to the right. When I do that, I subtract. Because I moved it one place, I'll subtract 1 from the exponent. Negative 13 minus 1, negative 14. So this quotient, the result from the division, is 2 times 10 to the negative 14. Example 3 is for you to try, and we're going to try a whole bunch of examples today. Please pause the video here and multiply these two numbers that are written in scientific notation. We began by multiplying 3.7 by 6.2. That gave me 22.94. 10 to the 9th times 10 to the 1st is 10 to the 10th. 22.94 times 10 to the 10th. But that number's not in proper scientific notation. Move it one place to the left, 2.294, and because it went to the left, I add 10 to the 11th. Example 4 is for you to try also. Please pause the video here and give this example a try. We begin by dividing 8 by 1.6. That gives me the number 5. Then we do our powers of 10. Negative 3 minus 5 is negative 8. This number is already written in scientific notation because 5 is a number between 1 and 9. How about example 5? Let's see if you can do this one. Please pause the video here. We began by multiplying 9.5 by 4.3. That's 40.85. Then we multiplied our powers of 10. 7 plus negative 4 is 3. 40.85 times 10 to the 3rd. I need to move my decimal point one place to the left, so I have 4.085. Because I moved to the left one place, Lars tells me I'm going to add 1 to my exponent, so it's times 10 to the 4th. Please try example 6. Pause the video here and let's see how you do. We began by dividing the decimals. 1.9 divided by 3.8. That gives me 0.5. We divide the powers of 10. 9 minus 5 is 4, so 0.5 times 10 to the 4th. Now we've got to move our decimal point one place to the right. Because I'm moving it to the right, Lars tells me when I go right, I subtract. So I had 10 to the fourth, subtract 1, I now have 10 to the third. 5 times 10 to the third. Please try example 7. We began this example by multiplying 7.8 by 2.4. That gives us 18.72. 10 to the negative 5 and 10 to the negative 2 is 10 to the negative 7. I need to move my decimal to the left, and Lars tells me when I go left, I add. Negative 7 plus 1 is negative 6. So 1.872 times 10 to the negative 6. How about example 8? Can you do this one? Please pause the video and let's see how you do. 6.4 divided by 8 is 0.8. 10 to the fifth divided by 10 to the second is 10 to the third. Move that decimal point to the right, and Lars tells me when I go right, I subtract from the exponent. So I now have 8 times 10 to the second. Suppose we have some word problems where we need to work with scientific notation. The best thing to do is begin by writing all the numbers in scientific notation and then use the properties that we've learned. In our first example, it says that the galaxy is 5.6 times 10 to the 19 miles across. How long would it take a spaceship to cross the galaxy if that spaceship is traveling at 25,000 miles per hour? Well, 25,000 is 2.5 times 10 to the fourth. I have 5.6 times 10 to the 19th divided by 2.5 times 10 to the fourth. That gives me 2.24 times 10 to the 15 hours. It would take quite a long time for that spaceship to make it across the galaxy. In example 2, it discusses the gross national debt of our country. On January 26, 2011, the debt was approximately 1.4 times 10 to the $13. That's a whole lot of money. How much would each American have to pay in order to pay off the debt if the estimated population is 3.1 times 10 to the 8th? Well, we're going to divide the total amount of debt by the total number of people. See how much each person would have to pay. 1.4 times 10 to the 13 divided by 3.1 times 10 to the 8th. That gives me 0.4516129032 times 10 to the 5th. Let's write that in normal notation. About $45,161 is the amount that each person in our country would have to pay in order to pay off the debt. Now, this was a couple of years ago. It's probably much more now. In example 3, we know that the speed of light is 186,000 miles per second. That's pretty fast. We want to know how many miles light travels in one day. Well, we need to do two things. The first thing we need to do is determine how many seconds there are in a day. The second thing we need to do is find out what the speed of light is in scientific notation. We begin by determining that there are 86,400 seconds in a day. We also know that there are 186,000 miles per second. 1.86 times 10 to the 5th multiplied by 8.64 times 10 to the 4th. I end up with 16.0704 times 10 to the 9th, and in proper scientific notation, approximately 1.6 times 10 to the 10th. In our last example, we have a computer that's doing arithmetic operations. 1 times 1, 3 times 5, 6 plus 8. You get the idea. It does one operation in 1 times 10 to the negative 7 seconds. It's a pretty fast computer. They want us to use scientific notation to determine how many operations it can perform in 1 minute. Well, because our time is given in seconds, we've got to convert the 1 minute to 60 seconds. Now let's write our numbers. 60 seconds is 6 times 10 to the first. The number of operations is given by 1 times 10 to the negative 7. Perform the division, and I end up with 6 times 10 to the 8th calculations. It looks like this computer can perform a whole lot of operations in 1 minute. So here's what you need to know. In order to multiply numbers written in scientific notation, simply multiply the decimals, multiply the powers of 10, and then rewrite the number so that it's in proper scientific notation. If you're dividing, divide the decimals, then divide the powers of 10. Then write your number in proper scientific notation. If you're having trouble working with the exponent when you move your decimal left or right, just remember my friend Lars. If you move it left, you add. If you move it right, you subtract. This is everything you need to know about multiplying and dividing numbers that are written in scientific notation.